My name is Don Megan, and I am one of the resident nerds here at the Math Science Innovation Center. I'm here to answer a question one of you posted on our Ask a Nerd feature. The question is, are there colors that we can't see with our eyes? The definitive answer is no, but yes. Color is the aspect of things that's caused by differing qualities of light being reflected or emitted by them. This perception of color derives from the stimulation of photoreceptor cells in our eyes by electromagnetic radiation wavelengths of light. What do you need to see color? Well, you need two things. You need light, and you need some kind of receptor that can see that light. So first of all, light. Light is part of the spectrum of electromagnetic energy called, appropriately enough, the electromagnetic spectrum. Visible light is simply electromagnetic radiation in a range of wavelengths that our eye is sensitive to. Less than 1% of all light that reaches us is in the visible spectrum. By most estimates, it comes out to be about 0.0035% of the entire electromagnetic spectrum. Our eyes can only detect light in the visible region of that electromagnetic spectrum, which corresponds to wavelengths of about 400 nanometers, that's in the violet region, to about 700 nanometers, which is the red region. In school, we're taught the pneumatic name Roy G. Biv to remember the colors of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. All other wavelengths of the electromagnetic spectrum are invisible to the human eye. So why do objects appear to be the color we see them as? As white light, for example sunlight, or what's really the collection of all 7 of those colors mixed together. A colored object, for example a red apple, absorbs all of the wavelengths of light corresponding to all of the colors except, in the case of the red apple, the red light, which it reflects into our eyes. Thus we see the apple is red. Since the only wavelengths of light our eyes can detect correspond only to Roy G. Biv, they are the only colors we can see. So, short answer, no, there are no other colors we can't see with our eyes, because color is defined as those wavelengths that we can see with our eyes. However, there are other wavelengths of radiation that we cannot see because they don't make up the visible spectrum. That is, they're not in the region that we define as color. The electromagnetic spectrum covers a huge range of wavelengths, as I mentioned earlier, ranging from very low energy long wavelengths that we refer to as radio waves, through microwaves, into the infrared, before becoming visible light, and then into the ultraviolet, then on to X-rays and gamma rays at the high energy short wavelengths. Although humans and most mammals can only see visible light, other animals can see into the infrared and the ultraviolet regions. Before I finish up, I'd like to address the second requirement for seeing color that I mentioned earlier. The first, remember, was that light was needed. We covered light. Next was the presence of a receptor to see that light. So if we expand the word see to a more general detect, let's think about some of our senses other than the sense of sight. For example, our sense of touch or our skin. Our skin can detect or see light, which is radiation in the invisible to the eye infrared region of the electromagnetic spectrum. Similarly, our skin cells can detect invisible ultraviolet radiation, which shows up in the form of sunburn. Also, our ears can detect, that is hear, or, quote, see, audible sound waves, which are in the region of the electromagnetic spectrum from about 0.017 meters to about 17 meters. That's about 6 times the range of the visible light range. So, if we expand our definition of see to include perceive or detect, our human bodies can see a lot more than just what we define as color or light. And lastly, don't forget about technology. We can detect virtually all of the radiation in the electromagnetic spectrum, from radio waves all the way through visible light to the gamma rays, using inventions as common as the radio and TV and cell phones to things like night vision goggles and X-ray machines, and into more exotic things like Geiger counters and gamma ray cloud chambers. So the complete answer is not as simple as it might seem at first, proving that your question was a very good one. Thanks for asking. On the same site as you found this video, there's a PowerPoint presentation with the same information, but accompanied by some visual aids to help you understand better. Thank you for giving us at the Math Science Innovation Center a chance to answer your questions. And keep being a scientist.